So solving this system with using substitution, it's already in the correct form because I already know that y equals x plus 2. As long as I have some variable equals something in terms of the other variable, I'm in good shape, and they gave it to us exactly like we would want it. And why do we want it that way? Because I have 4x plus, and now I have y. But instead of y, I'm going to substitute x plus 2. And then that equals 4. So now it's going to be pretty easy to solve. We have 4x plus x is 5x plus 2 equals 4. 5x equals 2. X equals 2/5, comma, and I need to find my y. To find my y, the easiest thing is probably just to plug it into that second equation. I know y is equal to x, which we said is 2/5 plus 2. Let's get a common denominator. So 10/5, which gives me 12/5. And so my ordered pair is 2/5, comma, 12/5. And that is substitution. All right, so now, next slide, we're going to talk, so solving systems using substitution. Basically, I already talked you through it, but if you want it in more formal terms, so first, solve one of the equations for x in terms of y or y in terms of x. So we were already given y in terms of x, so I didn't have to do anything. Substitute for the appropriate variable into the other equation and solve for the variable that remains. That's what they mean here. So I plug this into here and I solve for the variable that remained, which was x. Substitute the value from step 2, which was my x, into either one of the other equations, and then we're going to solve for y, and then we're going to write it as an ordered pair. I'm not going to check them, but I would highly recommend, if you do this and you're not sure, that you check the answers, just like I checked the answer when I graphed it. Just plug those numbers back in and make sure they work, and then you'll know for sure you got it right. So this to me is more the way that we would, or that I would, solve a system of equations. Maybe if I had that other one where the y was already separated, I might do substitution. But here you can see that if I solve for either x or y, I'm going to end up with a lot of fractions. And that is not going to be very helpful. Let me show you how to do it using elimination. We want to put them in the same order. So I'm going to change the order of this so that x is first and y is second. So now I have x's together, y's together, and then my solutions. Why we call it elimination is because we're going to first eliminate one variable. And how we're going to do that is we're allowed to multiply either equation by something. And then if we add them together, we're going to get some other equation. So I have to decide if I want to eliminate x or y. Maybe for this one, I'll do both. So the easiest one to eliminate, in my opinion, would be the y, because they're multiples of each other. Basically, it's like looking for the least common multiple. Or if you don't know what that means, it's like finding the least common denominator, where you want those values to be equal. So for example, if I multiply everything here by 2, I'm going to get, and I'm going to go down this way, I get 4x minus 6y equals 14. And when I say everything, I mean both sides of the equation. And then I have 5x plus 6y equals 4. And this, I'm going to add them. I highly recommend you make sure the signs are different for the one that you're going to eliminate and add instead of subtracting, because notice these are going to cancel each other out. So this equals 18. Divide both sides by 9. I get x equals 2. So once I know x equals 2, I can plug it into either equation. I'm going to plug it into the easier one with the one with smaller numbers. So I get 2 times 2 minus 3y equals 7. So this is 4. I'm going to subtract 4 from both sides. And I get minus 3y equals 3. And then therefore y equals minus 1. So now I have my ordered pair here. I have x is 2 and y is minus 1. Now let's do it the other way, because I don't think I am doing a lot of these problems for you. Let's do it this time where we'll eliminate the y value first. Just so you can see it doesn't really matter. Whatever makes you happy. And then this is going to be 5x plus 6y equals 4. Now, the reason I say the other way was easier because I only had to multiply one equation, whereas here, I'm going to have to multiply both equations by something to get rid of the x. So the least common multiple between 2 and 5 is going to be 10, right? So I'm going to multiply this times negative 5, or it doesn't matter, make one of them negative and this by positive 2. It actually doesn't matter which one. I could have made the top one by positive 5 and the bottom one by negative 2. But what will turn out here is negative 10x plus 15y equals negative 35. And then I have 10x plus 12y is equal to 8. Now when I add them, these cancel. I get 27y is equal to negative 27. I divide both sides by 27 and I get y equals negative 1. Which, notice, matches exactly. So it was a little more difficult because I had to multiply both equations, but obviously it wasn't terribly difficult. And then the last thing I'm going to do is I'm going to plug in my number for y. So I have 2 times x minus 3 times minus 1 is equal to 7. I'm just going to go back to the original. I get 2x. This is plus 3. So I'm going to subtract 3 from both sides and this becomes 4. X equals 2. I have my same exact ordered pair, 2 comma negative 1. All right. So as you can see, it doesn't matter which one I eliminate, but there are, and as also you should be able to see, it was obviously this first one was the easier way to go because I didn't have to change both equations. Next. So solving systems using elimination. Again, write each equation in standard form. Remember, we had it here, and I said, make sure that the x's are together and the y's are together. That's what the first one means. Just make sure that you start with x, b, by plus equals c. Then you can multiply one or both equations by a constant that will create coefficients of x or y that are additive inverses. I called them finding the least common multiple. Combine the two equations using addition and solve for the variable that remains, which is what we did. Substitute back, which is what we did, and then write the equation as an ordered pair which we did. We did not check it, but because I got the same answer twice, I'm pretty sure that I couldn't have done that unless they were right. Now I wanted to do this one because I know sometimes people kind of panic when they see fractions. I'm going to do this problem for you so you can see how not to panic. I'm going to start off by writing 5/8 x minus 3/4 y equals 1/4. I don't want to work with fractions either. I don't hate them, but it's a lot easier to make mistakes using fractions. If I were to multiply everything here by, again, my least common denominator or my least common multiple, I would multiply by 8. And then I distribute. This becomes 8 times 5/8 x minus 8 times 3/4 y equals 8/4. And I'm just going to go across here. I'm going to cancel the 8 with the 8, and I get 5x. I'm going to cancel the 8 with the 4, which gives me a 2 here. So 2 times 3 is 6y equals, and 8/4 is obviously 2. Now, that's a lot easier to work with. And then I'm going to do the second problem. So I have 1/2 x minus 2/3 y equals 1. My least common denominator would be 2 times 3 because they have nothing in common. 1/2 x minus 6 times 2/3 y equals 6. And then I cancel this with this, and I get, this is a 3. So I get 3x. For the first one, I cancel this with this, I get a 2. So this becomes minus 4y equals 6. Multiply both equations. And again, it doesn't matter which one you eliminate. I'm going to eliminate x because I'm going to multiply by 5 and 3 instead of 6 and 4. But honestly, it's not going to make a difference. So I'm going to multiply the top equation by 3 and the bottom one by -5. Okay. All right. So I have here, let me write it down here and then I'll just copy it to the other page. So I have 15x minus 18y equals 6, and negative 15x plus 20y equals minus 30. Add these together, this cancels. I get 2y equals negative 24. Y is going to equal negative 12. And then I just need to put it back, but I want to put it back into my original equation because they were a lot smaller, if you remember. I'll pick this one. 3x minus 4 times y, which we said was minus 12, is equal to 6. 3x plus 48 equals 6. 3x equals negative 42. X is going to equal negative 14. I have x is equal to negative 14. Y is equal to negative 12. And I probably should put these values back into the other equation. So if you use one equation to solve it, you should use a different equation to check it. So I'm going to use this equation and plug those values in. And I had minus 6 times minus 12. So this is going to be 2 minus 70 plus 72 equals 2. Check. So we got the right answer. So this is my solution to this problem.